Hi, today we will have a look on this NMU. This is a Navigation Management Unit. You can see the ident plate. And this is called also GNSX. So I don't know exactly the purpose of this thing on an aircraft. On the rear we have two connectors with an incredible number of pins. Okay, on this connector there are only a few pins. This is probably the power supply input. So first let's open this thing to see what is inside. Okay, so this is interesting. The boards are interconnected using this flat flex. So let's remove the boards one by one. Let's start with the first one. Okay, so this board is called the CPU. So obviously we have the CPU somewhere. So we have two Zilog parts. So I don't know exactly the purpose of these parts. So this one is quite large, since that there are 24 pins on that side. So this is the Z16C0110 PSC. There is a crystal oscillator here at 32.1 MHz. That code 92, 91 here. And the second Zilog part is at Z080-360. We have here 6 EEPROMs, which contains the code obviously. And here we have an LM193. It's a dual comparator. And this is the Dallas DS1232. And we have here 4 programmable devices. These are maybe CPLDs. And we have 3 latches. And we have here a board with, as you can see, at least 3 batteries. We can see that one has seen better days. So let's remove this board. This is probably the power supply board. So I think I need to remove the other board in order to get access to this one. So let's remove the second board. This one is full of flash memories. Look at that. These are 28F010. And here we have probably 2 CPLDs or something like that. And we have a voltage regulator, LM2931. And this transistor here, it seems VN2222. Okay, so this board is called 429 serial. So this is obviously an interface for ARINC 429 bus. As we can see, we have 5 parts here. These parts are probably the specific IC for ARINC 429 interface. And then we have the hardware interfaces here. These parts are called BD429. And here we have another big part, 7132 SA100P. That code 91, like the other parts. 9148 for these interfaces. And we have a Maxim part here, Max 359. Another one, and here we have quad exclusive OR gates, We have Xilinx FPGA, and this seems to be a processor Z84C0006. This is a Z80 CPU with the associated code, so it seems that this is an independent board. This one is also a digital board. It is called 422 serial, so this is also an interface board, but for RS 422 serial. So we have 5 identical parts. So I don't know exactly the purpose, but probably they are a kind of UART interfaces. And with a specific clock here, 2.88 MHz. So there is an EEPROM here. It is strange because I cannot see. Yes, okay, the CPU is here. This is another Z80, and we have also this part. It is the same as on the other board. I don't know the function of this part. Okay, so now it is possible to remove these 2 other screws. I think there is a connector. Perfect. Okay, so this is obviously a power supply board. So we have this classic pulse width modulation controller, UC2846. And we have 2 transformers here, and another one. And this is maybe a coil, or should be a transformer also. So we have this capacitor, which has seen better days also. And we have these batteries, which are a little bit destroyed. We can measure the voltage, but I don't expect to find something across these batteries. Okay, there is absolutely nothing, as expected. They are totally empty. So these are accumulators, 1.2 volt, 500 milliamp hour. So we have here on the top one linear regulator, 12 volts, LM340. This is totally obscure for me. This is a rectifier, probably a dual diode. The reference is UES2403. And on the left here we have 2 MOSFET transistors, IRF 540. Okay, so now it seems that we have 4 analog boards. Let's see the first one. Okay, so that's interesting. So we have here a quad comparator, LM139. This is interesting. So these are a very accurate resistor array. So this should be 10 kilo ohm resistors. 8 resistors probably between 2 opposite pins. And we have several op-amps, OP400. So this is a quad op-amp, but this is a very accurate op-amp actually. I think it is still produced. This is a nice op-amp for accurate measurements. I think quite expensive today. And you can see that we have several resistors array here. So this one is a 100K, 8 resistors of 100K. As you can see, we have several of these resistors array. And we have in the middle here 2 parts from NEC. So this board is called analog input. These parts are probably ADCs. I will try to find the datasheet. So we have a few digital parts here. So this is a CD 4030. I don't know. There is another one here. Otherwise, we have only op-amps, always the same, OP400 and and the resistor arrays here, 10K and 100K, and also comparators. So there is also an HC139. This is maybe a decoder. I will play the datasheet also. And here there is an HC589. Okay, so this is also a very nice board. The boards are very well designed. There are no budgies. So we found still the same op-amp, OP400. Here we have a 54 HC109. I don't know the reference. I will add a datasheet, comparators. And we have another one here, 7004. Oh, this is a transistor, a MOSFET, IRF F123. This is an LM295. I don't know. This one is difficult to read. This is also an LM295. And here we have an LM317. This is a linear regulator. And here we have also, they are identical. So we have a series of linear regulators here. This thing was not expensive. You can have this device for £3 or something like that. And here we have a PM155. This is probably an op-amp. I will add the datasheet. Okay, so we have another analog board. It seems more or less we have others, OP400 here. And this is a REF02, so this is a voltage reference, very accurate. We have a small read relay here. We have another quad op-amp, and this is a Logic IC, 54 HC160. I don't know this part. I will add the datasheet as well. And this seems to be also an LM317, another voltage regulator. And we have here a few Logic ICs, an HC125. I have already used this thing in the past, if I remember, 20 years ago or something like that. I think this should be a buffer with an enable signal, which permits to have an open output. I will check. And here we have a dual D flip-flop, very classic. And here on the left we have 4 identical parts. They are called COP 352. And there is another read relay. This is an HC14, so this is X inverters with the Schmitt trigger input. And this is an HC32. So this one is also an analog board. This board is called analog out. We have something identical on the right and on the left, as you can see. So we have op-amps, the resistor arrays here, and we have something interesting. So these are multiplying DACs. We have 3 of them here, and we have also the same on the second half of the board. This seems to be 2 push-pull outputs. You can see that we have 4 10 ohms resistors, so they are probably connected to the emitters of this thing. So we can test if you have one PNP and one NPN. Normally on this TO126, the base should be, I think, on the right. Okay, so here we have a NPN transistor. Okay, so we have 2 junctions here. So probably, okay, and this is effectively a PNP transistor. Okay, so we have effectively 2 push-pull outputs here. And this is interesting. So we have an ADC here, ADC 0832. We have two transistors here also, 2N2222 and 2N2907. So this is maybe another push-pull output with these resistors connected to the emitters. So it seems that we have 5 outputs, 2 on the left, 2 on the right, and 1 in the middle here. So let's see the last one. So the last one is different. Okay, on this board we have only transformers, and this is called the magnetics module. So this is interesting because we can see that we have 5 transformers. So we have 2 identical transformers here, 2 identical here, and we have 2 transformers here also. These are not transformers for power supplies, because the power supply was on the first board. If we look at these two boards together, this seems interesting because these two boards are probably used to generate 2 synchro outputs. That makes sense because these 2 push-pull outputs permit probably to have a resolver system, that is to say a 2 sine signal, but with one which depends on the sine, the other one on the cosine of the angle to be set, and then these 2 push-pull outputs are probably fed to these transformers, which are called actually Scott transformers, and this permits to have 2 synchro outputs. This one and this one are probably used for the reference of the synchro. So we can see that we have also 4 rectifying diodes here, which are connected to this transformer here, and the same for the second half. So these diodes are probably used for the measurement of the reference voltage of the reference input here. I think it can be possible to do something with this. What I would like to do is to do the small reverse engineering of this board, because normally when you want to do a digital to synchro converters, the best way is first to generate a resolver system, that is to say one signal which depends on the sign. You have the variable part, okay, and this is multiplied by the sine of the angle you want to set. So this is the first signal, and you have another one. It is the same signal at 400 Hz, but with an amplitude which depends on the cosine. So this is called the resolver system. So you have 2 signals like that. And in order to generate a synchro, you use Scott transformers. So you have a first transformer here with a middle point with a ratio of 1 to 1. And you have another transformer here with a ratio of, if I remember, 2 divided by square root of 3 to 1. And then you connect this signal here, and you have your 3 signals for the synchro. Okay, so this signal here would be the same as this one, that is to say sine omega t multiplied by the sine of the angle. So normally here, if I remember, you should have the signal with an amplitude which depends on the sine of the angle plus 120 degrees. So I don't know the direction. And you have here a signal which is the sine multiplied by the sine of the angle plus 240 degrees. In order to have a good accuracy on the angle of the synchro, you should have this ratio which should be accurate. So 1 is a specific one with 2 divided by square root of 3, so this is 0.866 and something like that. And this is a 1-to-1 transformer. And then you connect this thing to a synchro. So this is probably what is performed with this transformer. So I will just check if one has a middle point which is connected to the second one, and in this case this will be more or less a proof that this thing is effectively a digital to synchro converter. And if it is the case, I will try to do the reverse engineering of this one. Thanks for watching and see you next time. Bye bye.